Hello there. We're going to continue on with the Powerball question. The probability, as we saw in the previous slide, of winning something on any given Powerball ticket is about 2.85%. I actually stored the whole number in my calculator, so I'm going to be using the exact form and not this rounded one. And I'm going to start by creating a weighting table. So on the left, number of tickets until the first win. This is important because otherwise the chance that you win on your 10th ticket is win something is 2.85%. The chance that you win on your 100th ticket is 2.85%. But we're looking at probability that it takes until the 10th ticket, that it takes until the 100th ticket. So you can generate the numbers here. We're going to go 1 through, 100. And remember, you can quickly get this by using that sequence feature, sequence x, x, 1, 100. I might actually want to go further in this one, so I might redo it for 100% or 200 or 1,000. That would take a long time. Okay, the probability of that. Well, I know for this first one over here, the probability of winning the prize on the first attempt is 2.85%, but probability of winning it on the second attempt is not going to be 2.85% again. It's going to shrink because it means that I didn't get it on the first attempt and then I did get it on that second attempt. So I have to do the probability of not getting it times the probability of getting it. Then for this third one, I got to do the probability that I don't get it on the first one times the probability I don't get it on the second one times the probability I do get it on the third one. This is why the numbers shrink here. I'm adding more and more conditions. I don't get it, and then I do get it. But this is going to take a really, really long time to get all of those, so it's actually going to be faster if I define my rule here as this is the probability that I don't get it, which was our 97.15%, and I might want to use 1 minus the probability that I do get it in A, and this is going to be raised to the power of L1 minus 1 times the probability that I do get it, which is 2.85. And that continues too. And it's important to have this L1 minus 1 here, because down here on 3, when I do the 3 minus 1 is 2, I'm not getting it twice in a row. I don't get it on the first one, and I don't get it on the second one. The third one, I do get it. And then you can generate your whole list all at once. Okay, and that continues on down. And then we begin to have questions about, well, what's a rare event? How long will it take before it's unusual that I haven't won anything in the Powerball yet? And here I have to remember that the cutoff is only 5%. So 5% of the time it's going to take longer and longer and longer. Well, this number is under 5%, but taking it right away on the first try, and it's unusual that it's going to happen right away on the first try, but I want to, everything would be considered rare from then on out. So I'm really looking for the idea of, so-and-so has been playing the Powerball for years and years, buying a ticket every day, and they've won nothing. We're not talking about the jackpot and such, we're also talking about just winning the $3 prize. So I need to start adding all of these up here. I need to take a cumulative running sum of these numbers here. And the way that I can do that is to establish in list 3 just a cumulative sum of these numbers over here in list 2. So cumulative sum is simply adding these numbers up. You'll notice that getting it within the first try, that's 2.85%. Within the first 2 tries is this number and this number, so that's a 5.61% chance of getting it within the first 2. And then I get to tack on this one. So getting it within the first 4 attempts, I have just over a 10%, almost an 11% chance. Still not, so the vast majority of the time it's going to take longer than 4 attempts. It's going to take 89.91% of the time. It's going to take more than 4 attempts. And I want this number to shrink. I want this number that's going to take more than something to be really, really small, so that I've probably gotten it within the 5 years of playing this every day, that I've gotten something. So this number needs to be small, which means that these numbers need to be large, and I need this to grow to be bigger than 95%, so this is smaller than 5%. So you're going to have to scroll in your table. Right, so I had to scroll for quite a while. I actually had to redo how far my list went. 1 through 100 wasn't quite enough, as you see, so I went further than that. I went up to 200, which took the calculator a while. Only probably had to go well, obviously just up to 105, but I didn't know that. Then I did redefine these, did the cumulative list, so we see these cutoffs here, and we want to interpret them. So the 103, you have a 94.9% chance of getting it within the first 103. Well, that means that what comes after the 103 is a 5.1% chance, and that's bigger than the 5% that we're saying a rare event is. Rare event is we're saying that happens less than 5% of the time. So not getting a winning Powerball ticket, of course by winning we're saying that you're winning something, probably $3, not getting that until the 104th day of buying a ticket every day, that is not actually all that unusual. You should have gotten it before that 94.9% of the time. So it's going to take more than that 5.1% of the time. And that's not under 5%. So you actually have to go further. If I treat the 104 as the cutoff, over 95% of the time, 95.05% of the time, I get it within the first 104 tickets. So to take longer than that happens less than 5%, 4.95%. So to be a rare event, it would be considered rare to need 105 tickets or more. So there's different ways of talking about this inequality. It's rare to need over 104, or on the 105th, 105 would be considered rare. Getting it on the 104th itself would not be considered rare. So these problems are tricky because of where the different cutoffs wind up lining up. And you have to ask yourselves questions of what is it added up to this point? Is this 95%? And what's remaining under 5%, or have what I left remaining to be bigger? And this 105 here, I found that my cutoff is 104. That's where I have a 95% chance of getting it within the first 104 tickets. Beyond that, there's only a 4.95% chance it's less than 5%, so to need more than 104 tickets would be rare, or to not get it until the 105th ticket would be considered rare. Tricky problem. We're going to look at the expected waiting time next. Character and Scholarship for Life.